Okay, so I wanted to do a division of polynomials where the denominator was not a linear factor in that form, x minus k. We've seen a few of those and used synthetic division, which is real nice because it's nice and easy. But if it's not in that form, x minus k, if you had 2x plus a number or something like that, or in this case 2x squared or a higher degree polynomial as your divisor, you're not going to be able to use synthetic division. So you need to know how to divide it regardless of what the degree of your polynomial is. Okay, so we're going to divide these polynomials, and I'm going to do that in a second. But first I want to talk about this division algorithm, because it seems a little confusing. I think it's maybe a little easier to think of it in this form. The dividend divided by the divisor equals the quotient plus the remainder divided by the divisor. And it's the same sort of thing. You can think of 42/5 as 42 divided by 5, right? If you divide 5 into 42, it goes 8 times. 8 times 5 is 40, subtract, and you get a remainder of 2. So you can think of that as 8, that's the quotient, plus 2, that's the remainder, over the divisor 5. So 42 divided by 5 is 8 and 2/5. Well, the same thing holds when you divide with polynomials. So let's do out the division now. So we're going to write the divisor out here. So it's going to be 2x squared minus 3. And we're going to divide that into 8x cubed plus 10x squared minus 8x minus 13. Okay, so you're looking at the leading coefficients here. You're saying, how many times does 2x squared go into 4x cubed? Sorry, I'm projecting here. How many times does 2x squared go into 8x cubed? So basically you're saying 8x cubed divided by 2x squared is what? Right? And that's going to be 4x. So write that above here. That's going to be part of our quotient. But I got to distribute this to both terms here. So it's going to be 4x times 2x squared. That gives us 8x cubed. And then 4x times minus 3 is minus 12x. Whoops. Now look, I put this under the x squared term. We want it under like terms, so you don't want to write it there. I'm going to erase that. We want to write it under like terms. So you want, every time you multiply these things, you want to write things under like terms here. So I put it under the minus 8x. Okay, now we're subtracting these. But instead of subtracting, for me, it's easier to think of adding the opposite, which is the same thing. So I'm going to change the sign of this. I'm going to make this minus 8x cubed and this plus 12x. And then I'm going to add these polynomials together. So 8x cubed plus a negative 8x cubed is 0. That's what we wanted. We get 10x squared. There's nothing here, so it's just going to be 10x squared. Minus 8x plus 12x is going to be plus 4x. And then we can bring down this next term, minus 13. So we do the same thing. We look at the leading coefficient and we say 2x squared. How many times does that go into 10x squared? That's going to be plus 5. And we got to distribute again. So it's 5 times 2x squared. That's going to be 10x squared. Plus 5 times minus 3 is minus 15. And I'm not going to make the same mistake. I'm not going to put it under the x term. I'm going to put it under the constant term. So we're subtracting, so I'm going to add the opposite. So I'm going to change this to a minus 10x squared and change this to a plus 15. Add these together, we get 0. This is going to be 4x. And then negative 13 plus 15 is plus 2. Okay. Now, 2x squared goes into 4x how many times? Well, the degree of this of the divisor now is bigger than the degree of this term here, so we're done. This here is our quotient, so we're going to say that this is equal to 4x plus 5, and this here is our remainder. And we're going to put the remainder, so it's going to be plus the remainder, which is 4x plus 2, all over the original divisor, which was 2x squared minus 3. So that's it. When we divide those polynomials, we end up with 4x plus 5 plus the quantity 4x plus 2 all over the quantity 2x squared minus 3. So hopefully that helps. Remember, you want to be able to divide any kind of polynomial, regardless of what the degree that your denominator is. So you're not going to always be able to use synthetic division. So be able to do it both ways, not just with synthetic division.